Okay, so today we will just see the procedure for formation of ZBUS. Part of it we have already covered, but not in detail. So I will again revise the thing and again go for the next. So we had seen that if we have a power system containing node 1, node 2, node 3, node 4, node P, node I, node reference node. Okay. And let us say I am going to add a branch to the network. Now you know what is branch and what is a link. So I am going to add one more node to the network, which is having an impedance small ZPQ or ZPQ. Okay, so this ZPQ is the impedance of this branch, which is connected between P and Q. P is an existing node in the network, and I am going to add another node Q through a branch which is having an impedance ZPQ. So what I am indicating here is my original ZBus which is already available. Okay, up to Zm. There are already M bus network which is already available. That is what I am asking. So I have got this Z bus available with me. It has got a node P and which is already there in this network, and I am going to add a new branch between node P and a new node Q which is having ZPQ as the impedance. So obviously the size of the ZBus which was earlier M by M, because there were M nodes, so size of ZBus will be M by M, will now increase by 1. So one more node Q will be added. So one more row here, one more column here, that will be added. So now it will be M plus 1 by M plus 1 because of this Qth node which is added. So what will be the entries of this ZBus, which is new ZBus now? So what happens is the earlier ZBus is intact. It doesn't change anything there. Only thing we have got an addition of a row and addition of a column. And these elements, that is ZQ1, ZQ2, ZQ3, ZQM, and Z1Q, Z2Q, Z2, Z3Q, ZPQ, ZMQ, these are to be evaluated, and also ZQQ is also to be evaluated. So in the last lecture we have just derived a very simple formula that it is very easy to evaluate. Once you know this is already known, this much ZBus is already known. So only thing that is need to be calculated is what will be this row. Now calculation of this row is very simple. You just copy the pth row, that is the node where you are going to add a new branch from here to node Q. Node Q is a new node. So I am going to add a new branch between node P and node. So that pth bus row, that is ZP1, ZP2, ZP3, ZP4, ZPM. Okay. This is to be copied in this row. Or in other words, by formula what I want to say says ZQ1 is equal to ZP1, ZQ2 is equal to ZP2, ZQ3 is equal to ZP3, ZQM is equal to ZPM. Okay. So this is how this last row is calculated. Now since ZBus is a symmetric matrix, Z1Q is equal to ZQ1, which is now known. Z2Q is equal to ZQ2, but ZQ2 is equal to ZP2, so that is known. Similarly, ZMQ is equal to ZQM, that is also known. So this row and this column is very simple. There is one formula which you need to remember about ZQQ, and ZQQ is equal to capital ZPQ. This is capital Z. Okay. So this capital Z means the entry in the original Y bus, which is ZPQ. So somewhere it will be here. So here it will be capital, or let me write with some new color. It might be ZPQ. So this capital ZPQ, okay, that is this entry plus, yeah, just hold. I should, this already there, yeah, this is already here. So capital ZPQ is already calculated. So capital ZPQ, so ZQQ will be this capital ZPQ plus small ZPQ, which is the self impedance. So this is basically small ZPQ. This is referred to in the stack book because there are mutual couplings also taken there which we are not considering, otherwise formula becomes too complex. So a simple formula is there that this ZQQ is equal to ZPQ, okay, from this entry plus ZPQPQ, which is the impedance of this line, this new branch that is being added. Okay, so that is the simple way to calculate, and the new size will now be m plus 1 by m plus 1, because one more node is added. Already m nodes were there, we have added one more node. So it is will be m plus 1 by m plus 1. Now there can be some special case, in which case suppose this P is not a regular node but it is a reference. Okay, it is not a regular node but it is a reference node. So a branch is added to a reference node. So P is 0 because the reference node we treated as 0, and Q is not 0, Q is the new node. Okay, so by the same formula, ZPI is equal to ZQI, or sorry, ZQI is equal to ZPI. But write this I also. So ZQI is equal to ZPI, but P is 0, so it will be Z0I, and there is no entry as Z0 because the entry starts from 1. So make it 0. Z0I is 0. So this is 0, and therefore ZQI is 0. So in case it is a reference bus, this ZQ1 will be equal to Z01, which is 0. Then ZQ2 will be equal to Z02, which is 0. So all these row will be 0. Similarly, all these columns will be 0. And ZQQ, which is the entry here, ZQQ, that will be equal to ZPQ plus ZPQPQ, which is the self impedance of that branch. Now ZPQ is what? Capital ZPQ, not small z. Capital ZPQ will be P is 0, so Z0Q. So there is no index at 0, so it will be 0, and this will be ZPQPQ. So ZQQ will be equal to ZPQPQ. That is the only change that will happen. So what change will happen in case it is a reference node? In case it is a reference node, only change that is going to happen is all these entries will be 0. This will be 0, this will be 0, this will be 0, this will be 0. Similarly, all these column entries will be 0, and this ZQQ will only be equal to ZPQPQ. Let me just erase this because it is not very clear. This is PQ. Yes. So only change that is this. So formula remains same, but you put P 0 and Z03 or Z04 has no value, 0 value. So you take it as 0. Okay, so this is as simple as that. Now we come to addition of a link, which means now that we are going to add an element between two nodes, and those two nodes, they are already part of the existing network. In earlier here in this case, what we had done, that this Q is a new node. It was not a part of earlier node. But now we are considering a case where we are adding an element between an existing node P and an existing node Q. And then we want to calculate what will be ZBUS. So the derivation is little bit complex. I will not go into the derivation, but I will tell you a simple formula or the approach. So what we do is we create a temporary node L. Okay, we create a temporary node L. So then it becomes an addition of a branch with one end as P. Okay. And later on we will eliminate this node L. So, but first let us add one node L. So the procedure is simple: ZL1, ZL2, ZL3, ZL4, ZLN. And here also there will be one column added: Z1L, Z2L, Z3L, Z4L, ZPL, ZQL, ZML, and last this entry will be ZL. Now here the formula is simple. Formula is this row, how to calculate. This row is equal to, now we know that P and Q are both existing. Okay. So it is, you concentrate on this row, pth row. Okay. Concentrate on the pth row. And you concentrate on the qth. In between there are rows, so I am not indicating that, but there are rows in between. So the formula is ZL1 is ZP1 minus ZQ. ZL2 is ZP2 minus ZQ. ZLM is equal to ZPM minus ZQ. So the formula is very simple. The two rows between which we are adding a link. Okay. So that will be this additional row that is created as temporary row, that will be equal to ZPL minus ZP I minus ZQI. So in general, so this row is equal to this row minus this. So this minus this is this. ZP2 minus ZQ2 is ZL2. ZPM minus ZQM is ZL. And since it is symmetric, ZL1 we know, so we can know what is Z1L, Z2L, Z3L, Z4L, ZPL, ZQL, ZML. So all this we can find out. And now remains only to find out what will be ZLL. The formula is ZLL is equal to ZPL minus ZQL. Formula remains same, ZPL minus ZQL. So again we are subtracting this. So this minus this plus one additional thing, which is the self impedance of the element which is being added between P and Q. So ZLL is the element which is being the last element. This is ZLL. This is equal to ZPL minus ZQL. So formula is this minus this remains same. In addition, we have to just add the self impedance of the PQ branch. Okay, PQ link, not PQ branch, PQ link. So just that, nothing else. And now this is a temporary solution. So we have just added, as I said, we have added or formed a temporary node L, which is not part of the original network, and then we eliminate that, and after elimination the formula becomes simple. So before elimination we calculate, since it is a new node, one row and one column is going to be added. What will be the values we have seen? The ZLL also is same formula, but in addition to that we have to also add the self impedance of the element which is being added between P and Q. This will be more clear when we do an example. So the new formula is such that after all we are adding a link, and if it is a link, that means we are just between two existing nodes we are putting some new element, that's all, which means the size of ZBus should ideally be what? Size of ZBus should not change. Size of ZBus will still be m by m. It should not change. So what we do is we again revert to the original m by m size. And how? Each one of this entry Z11, Z12, Z13, Z1m, or for that matter this complete entry as such, complete ZBus from, choose a bright color, I guess, blue color. So this complete ZBus, which is original ZBus, the size will remain m by m. Oh, sorry, it should be from here. Yeah, I have already indicated it. So this size will remain m by m. There is no problem about here. But each of this entry will be changed. And how it will be changed? The new value Zij will be equal to the old value minus ZIL into ZLJ divided by ZLL. So in general, if any ith column is there, so this is ZPI or Zij in general, whatever it is. So that will be equal to the new value will be equal to old value minus ZIL into ZLJ divided by ZL. This is the point. So ZIL means, so let us take the case of when I is equal to 2 and J is equal to 3. So ZI3 new, not Z23 new is equal to Z23 old minus Z2L into ZL3 divided by ZL. Okay. So 2 and 3, Z2L is this, and this multiplied by ZL3, it is somewhere here, ZL3, Z2L into ZL3 divided by ZL. Or I can also assume that Z2L is same as ZL2. So ZL2 into ZL3 divided by ZL. So that is the only thing that have to change. So again it will be the original size. Now here some special cases are there. That is when a link is added to a reference bus. Again the logic goes same, logic doesn't change. That means P is equal to 0. That is I am adding a link not between P and Q but between a reference bus and Q. So here what is being added is, this is my reference bus P and this is my some other bus Q, and I am adding a link between these. So P is equal to 0 in other words. So we know the process is same. We again form a temporary node, node L which will eliminate, and ZLI is equal to ZPI minus ZQI. The formula remains same. Only thing P is replaced with 0. So Z0I, but Z0I does not exist. It is 0. So it is equal to minus ZQI. And ZLL is equal to ZPL minus ZQL plus ZPQPQ. This formula also remains same. but only P is replaced with 0. So it will be Z0L, which does not exist. It is 0. So it will be 0 minus ZQL. ZQL is there. So it will be minus ZQL plus ZPQPQ. This is the only formula that is going to change. Otherwise, it is going to remain the same. So we will take a small example in the next lecture, and then I will explain. That will become clear to you. Okay, so we will stop here. Again, show desktop and stop sharing, and then file and meeting.